This is Steve Piloff from George Mason University. So now that we have understand compounding, we can have some tools in our chest that can allow us to solve problems where the rate that we need may not be the rate given. We can determine the appropriate rate and then figure out the appropriate period and then get the rate that we need. So remember, the rate that's relevant is the one that corresponds to a period. So you got to figure out what's the appropriate period for the problem. Is it a month? Is it a quarter? Is it a semi-annual period? Or is it a year? If the rate for the period is given, then you can use it. So if the relevant period is a quarter and you're given a quarterly rate, or if it's an annual period and you're given the annual rate, you're good to go. If the rate for the relevant period is not given, what would you be given? You'd be given an APR, which is an annual rate, and then the way to get the appropriate rate would be simply to divide by the number of periods in a year. So that's the way it's going to work in this course. So if you have a situation where the appropriate period is a quarter and you're told what the APR is, or you're told what the rate is, period, rate with nothing else, you assume, oh, that is an APR. Then you say, well, that's for a year and I need a quarter, I'll divide by 4. A couple of timeline tips, that things to focus on that help you figure out what the appropriate period is. If a rate's given, or if the question asks about a rate, and the period's smaller than a year, then that's what the timeline period. So if you're given a quarterly rate or a semi-annual rate, or you're asked for those kinds of things, monthly rate, then that is what the time period would be. The only exception is there are some problems where you figure out a monthly rate or a quarterly rate or a semi-annual rate, and then you need to convert it to an APR and EAR, more frequently an EAR. That's the only exception to that. But in general, if you're given a quarterly rate or a monthly rate or a semi-annual rate, that's the period that you need to work with. And even in this kind of a problem, you need to work with the quarter or the 6-month period, half year, or the month in order to get the appropriate period rate to convert it to the AR. If you get an annual rate and you're given the compounding period, then whatever that compounding period is, that's what the timeline period is going to be. If you're looking at an annuity due, or perpetuity, whatever frequency those cash flows take place, monthly, quarterly, semi-annually, then that's what the time period is on your timeline. And finally, and again, remember, these are tips for this class, not necessarily universal, but this is things to focus for students of this class. If everything's annual and nothing's less than annual, there's no talk of anything that's monthly or quarterly or semi-annually, then the timeline period's a year. And so again, these are some fairly simple things to key on to tell you what the timeline notches should be. And then you can figure out, okay, given that I need the monthly rate or the quarterly rate or the semi-annual rate, or in some cases the annual rate, what rate am I given? And do I need to do something to get the rate that corresponds to the right period? So let's take a look at some examples. And as it says here, the goal is to show that compounding, it doesn't make the number crunching more complex. The number crunching stays the same. The thing that, as the challenge that's been added, is you have to put in more thought as to setting up the timeline. What's the relevant period length? And therefore, once I have that, let me make sure I have the rate that corresponds to that period. So that's what we want to focus on. But the number crunching in these upcoming problems is nothing new. So you're buying a computer. You're going to pay $1,000 in 1 year. Discount rate is 9% compounded annually. Well, here's our timeline down at the bottom. Everything's a year. There's nothing in there that's less than a year. So in 1 year, one period, we'll pay 1,000. And the answer is going to be negative 1,000 divided by 1.09, which is negative $917.43. Under this conditions, I'd be indifferent between paying $917.43 today or paying 1,000 in 1 year. Similar terms. 1,000 is due in a year. Discount rate's 9%. But the interest rate or the discount rate is compounded semi-annually. Therefore, you can see the appropriate timeline down here you can see that there's two periods because the periods are a half year. We have semi-annual compounding. Whenever we're giving a compounded frequency, whatever that compounding period is, that's the timeline period. And what this means is, since it's 9% for the whole year, then every 6 months, compounding or discounting takes place 4.5%. So in two periods, in two half years, we owe 1,000. What's the present value of that? It's just negative 1,000 divided by 1.045 squared. So this problem up here is the exact same as saying $1,000 is due in 1 year and the discount rate is 4.5% per half year. But notice we get 915.73, which is a different answer than what we got on the previous problem, even though both of them involved paying $1,000 in 1 year, and both of them involved a discount rate of 9%. But because the compounding periods were different, the periods were different, there was some additional, discounting on discounting, and as a result, we wound up with a different answer, which could lead to a different optimal decision. And that's what that point says. And again, that little guy should be next to him. So negative 915.73. Finally, how much would Justin have in 3 years? He invests $5,000 today in an investment, return of 9.2% per year, compounded quarterly. So the compounding is quarterly. So therefore, we know that time periods are a quarter. We want to know how much he'll have in 3 years. Well, 3 years is 12 quarters. So we really want to know is how much he'll have in 12 quarters. And we're given the annual rate of 9.2%, which is how much he earns over a year. But what we really need to know is what's the quarterly rate. Well, 9.2% per quarter divided by 4 is 2.3%. 9.2% per year divided by 4 quarters per year is 2.3% per quarter. So the answer to this is simply 5,000 times 1.023 to the 12th. He would have $6,568.67. So again, this problem is the same as how much would he have in 3 years, how much would he have in 12 quarters if he invests 5,000 today, and it has a return of 2.3% per quarter. And if you did in the financial calculator, in 12 periods, at a rate of 2.3 puts in 5,000, you'd wind up with $6,568.67. This, I believe, is the last one. You borrow $25,000. You want to know what your monthly payment is. Annual rate of 7.44%. Payments are equal and made for 1 year, so we know there's 12 of them, and the first payment is due today. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 periods a month because there's monthly payments, so we need a monthly rate because we're given an annual rate. So the monthly rate is 62/100%. And now all we want to do is say, okay, what is the cash flow associated with an annuity due with a present value of negative 25,000 because our payments, we're getting 25, so what we pay back has to have a present value of 25. And so we want to find out what that rate is such that all 12 of these payments, when discounted by 62/100%, you add up all 12 is equal to negative 25,000. So there's 12 payments. The rate per month is 62/100. Present value is 25,000. We're in begin mode because our payments start today, and those payments will be negative $2,154.88. So once you do this work, this part is nothing new.